So the last question, question number 4 for this exam, and we can be over for this exam. It's actually a great thing because we didn't take a lot of time, even though I'm explaining the stuff and so on. It didn't take a lot of time, so this exam actually didn't take a lot of time from the student to check in and just solve the questions and so on. Even though I didn't do I skipped the calculation part, but still, I hope the exam will be in this kind of difficulty. So question number 1 is find all the root of z4 equal to negative 81. This kind of question I think I covered in the review of complex analysis. Not complex analysis. We still no we didn't go through the complex analysis yet. It's gonna be next year, but is find all the root for this question. So for this, I mean complex numbers. So z to the z z please write like a z. Okay, z to the fourth okay, thank God. Z to the fourth equal to negative 81. So we have the first thing we have to do is to just only we don't have even have to graph it. So z to the fourth is equal to negative 81. So the first thing you have to do is you find that that we want it as polar form. So a negative 81 will be equal to will be in a polar form will be equal to negative 81 tan cosine of pi plus I sine of pi. Because cosine of pi is negative 1, so it will give us a negative, no, it's 81, sorry. Usually with the modules we don't write the negative here. So 81 cosine of pi is negative, so the answer will be negative 1, and sine of pi will be equal to 0. There's no imaginary part. After that, we write the z. We say, okay, the root is equal to z1, and z1 will be equal to, we raise 81 to the power of 1/4, and so on. So we raise the power to 1/4, and pi will be equal to pi because the sine function is periodic, so it's pi plus 2 and pi, and the same thing with the cosine, pi plus 2 and pi, and then we revise it into the 1/4 or 81 to the 1/4 power, which I think equal to 3. Yep, 3 because so it's gonna be 3. 81 to the 1/4 will be equal to 3, I think. Yep. And cosine of pi plus n pi 2 and pi, this thing will divide it, the argument of the cosine we will divide it by 4 and put the number as we said in the complex review of complex number, we put it as an algorithm, so 0 1 2 3, and this by this the 4 complex answer will be generated. And as we said again in the review of the complex numbers, it should define an Argand diagram, a circle, Argand diagram of a circle. So this is the first question. The second question is so that G can be written as the derivative, partial derivatives can be written as this, where they give us some. So the discussion for A and B, the parts are easy, I guess. They give us a function of G of x and y, which will be equal to, oh, you scared me, equal to e to the x ln or log. It's like when he want log, he usually means log of pairs of e. So we put a slash or logarithm of 1 plus y. So what can we do with this function? And so the way I derive that it must be equal to that one is by deduction. I deduce that. So e to the x, if we just ignore this part, this is the way I thought about it. Ignore this part, e to the x, if we differentiate, no matter how much we differentiate it, will give us e to the x. So if we differentiate the function in time, in respect to x, the expression should be e to the x. So the only thing that's gonna vary is this expression. And the other thing is that there is a function of purely in terms of x, and the other function is purely in terms of y. So they should not interfere. So because with the partial function, this thing is a constant, and it's the only one here. And then once we want to take it as with respect to the y, this thing is a constant, and take when we want to take it as respect to y, this is constant different this one. Once we want to take it as x, this is constant, and we differentiate this one. And if you differentiated the ln of 1 plus y in time, the expression should be equal to n plus n. The expression should be equal to the left hand side, or the coefficient of e to the x. You can try it by the first derivative, the second derivative, the third derivative, and you can actually see that this thing is not a math course, like a pure proof math course. So it's enough to see the general trend of like three terms or 4 terms. You don't have to do a proof by induction. Those real stuff gonna be in your math foundation of math. But so far, that's the only thing you have to see. So hence or otherwise, write down the first term of the Taylor series of g of x or y about 0, 0 up to and including a term that are quadratic in x and y. That means the term that are quadratic will mean the degree of the monomial should be of should be equal to, it should be a second degree monomial generated about 0, 0. So we have we have the expression for the Taylor series will give us into the exam, but generally speaking, it's evaluating the function at 0, 0, and take the first derivative with respect to x, then take it with respect to y, and so on. And the equation of the Taylor series will be given in the exam. So we shouldn't worry about the Taylor series, because it's just applying the equation that's given in the exam. And that notes of the question. So the last part of the question, which is question C, I and 2, I cannot write that much because the pen does not work and I want to finish the videos today. So I will make it as explanation in words, in hope that everyone understands what I'm saying, and hope that everyone at least have an idea of what I'm saying. So f of x, y will be equal to 2x cubed plus 3x y plus 2y cubed. So first thing we will differentiate f with respect to x will be equal to 6x squared plus 3y, and at critical point we put it as 0. And take the derivative with respect to y will be equal to 3x plus 6y squared, and this thing will also should be equal to 0. And from this you can find out that 6x squared is equal to 3y, or y is equal to 2x squared. So this is the expression involving, y, you can put y, substitute the y back into the equation. So 3x plus 2 squared is 4. 4, this thing should be equal to 24 x to the 4th power is equal to 0. This means either x equal to 0. Since this function is a real function, we don't have to worry about the complex value, the complex value for those stuff. So it's either x equal to 0, or you can actually, a better way is actually to factor. So the better way is starting from this one. You factor 3 is a common factor here. You left as x plus 2y squared, and y squared is just 2x squared will be equal to 0. So this thing will be equal to 3 times x, and this thing will be 2 squared times 2 will be 8x cubed. No, 3x to the 4, this is a square, and so to the 4 will be equal to 0. So it's either x equal to 0 or x is equal to so either x is equal to 0. Let's do it slowly. So take x as a common factor, will be equal to 1 plus 8x cubed is equal to 0. And from this we say if x equal to 0, of x equal to -1/2. Yup, -1/2, because once you cube it, will give us 1 over 8, and 1 over 8, -1 over 8 times 8 is equal to -1, and -1 plus 1 will be equal to 0. So it's either x1 is equal to 0 or x2 will be equal to -1/2. For x1 equal to 0, so it's the critical point is 0. For x equal to 0, y equal to 0. And for x equal to -1/2, y is equal to 1/2. So from this we find the critical point and identify each type of them. We have right now to identify each type of them, so we have to use the determinant. It's fxx fyy minus fxy all square. With the determinant, if d is less than 0, then it's a saddle point. So if d is less than this is how I explain that. If d is less than 0, then it's a saddle point. If d is greater than 0, we look the sign of fxx. If d is greater than 0 and fxx, the second derivative of the function with respect to x is positive, then it's minimum. If it's negative, then it's maximum. So we see that for those stuff, let's just fill the point. So let's delete those stuff and just keep up with the point. So the point of the interest is 0, 0, and -1/2 and 1/2. Yep, the camera is still working. So take this one as f, and we find that f of x will be equal to, the function with respect to x will be equal to 12x. F of y, so we define the function, second function with respect to y, will give us to 12y. And f of x, each one, like f of x, so define the first function, the derivative with respect to y will give us equal to f of xy will be equal to 3. So we can see that for 0, 0, d is less than 0, so it's saddle. So it's saddle for negative 1 and negative half and half. Negative half and half will be equal to, this thing is a little bit, there's something that I should be careful about, and that thing is that there's a negative sign here. There's a negative sign here. So if there's a negative sign here, yeah, because once you switch it to this side, it'll be negative y and negative 3y. So if there's a negative sign here, then there's a negative sign here. And in between it does not matter because it just squares the function. But that's how people lose marks, by doing those silly mistakes, which I hate. But I have to be more careful. So it's x squared minus 3, which is definitely greater than 0. So we see the second derivative function. The second derivative function for this one will be equal to negative. So it's a maximum. So, and for it's a maximum point. So right now the last thing of this question is to draw the contour diagram. The contour diagram, and I really need water. So the contour diagram for this function, so this is the last thing. I don't know how the lecturers can do it. They can talk for hours. It's so tiring. But at the same time it's so rewarding. So for negative 1, I hope I didn't make any calculation mistakes. If I did, it's a calculation, it's an arithmetic mistake. There's nothing super hard about it. You can find it out. So for negative 1, there's a point here. Since it's saddle, so we those lines just to see the point. Since it's saddle, then the contour will encircle it. And it for 0, 0, it's a max. It's a critical point. So the contour will cross itself at 0, 0, and this is the contour diagram. Is this thing in the world is to draw the contour diagram. So this is the contour diagram. So and the critical point, it's encircle it, and no, I mean in the maximum minimum, it's the contour encircle the point, and in the what's called it, well, in the saddle point, the contour will cross itself, and the only point the contour will cross itself is in the saddle point. So this is the graph of the contour function, and we classified the type of the maximum and minimum. So let's go back to the question. Find the critical point of the function, identify each type of them. We found this thing, and do an approximation sketch for the contour of x and y. First question, I think it's worth 5 marks. It's just about taking the derivatives. Take the first derivative, put it as with respect to x, put it 0. Take the derivative with respect to y, put it 0. Find the second derivatives for all the types x, xy, and y. Apply this matrix. Oh, you know that because this thing came from Hassan, I think his name is matrix, Hassan matrix. So we know that this matrix, if d is greater than 0, if d is less than 0, then it's saddle point. If d is greater than 0, then it's either maximum or minimum. So you have to see the value of f(x)(x). If f of x(x) is greater than 0, so it's a minimum. If f(x)(x) is less than 0, so it's a maximum point. After that, you do a rough estimation for the contour graph, keeping in mind that minimum or the maximum, the contour will encircle itself, and it will close itself at the saddle point, and if anything in between, just circles and put those stuff together, and you will find the contour the contour for f of xx and for this function and any other function. And by this we have finished calculus and vectors review, the solution to the exam plus review for the things that we have to know. So this is the end of this thing. University of Manchester paid for me. I did a video about that. You have to pay for me. No, you don't have to pay, so it's like no one can like go and like make a lawsuit against me saying like I say to Manchester, you have to pay for me. But if you can't pay for me, I'm kidding.